Good morning, students. Welcome to today's session. I think every one of you understood what and all we have seen so far in the last video. I hope all of you understood about all the concepts and how to draw the graphs and what are the types of definitions and concepts under coordinate geometry. And also, I think every one of you know about what is abscissa and what is ordinate, and about the coordinate plane and how to plot the point on the coordinate plane, and what are the sections of the coordinate plane, and what are the quadrants of the coordinate plane, and what about the sign of a point in the first quadrant, second, third and fourth, and what about the distance from the x-axis of the point and the distance from the y-axis of the point. So everything you have seen in the last video. So I hope every one of you understood about that, and I hope that every one of you completed your classwork and also homework. So today we are going to enter into the new topic, that is polynomials. So already you know that what is polynomial. Okay, in your lowest section, that is in your 8th standard, you have seen that algebraic expressions. So in that so many expressions are available. So what is the expression mean? Is the combination of constant and also variables. So that is called an expression. And expression can be divided into, classified into according to the terms, and you already know that what is term and what is coefficient and what is an expression. So that is a continuation. Okay, polynomials. So in 9th standard they are given this as a new topic here. Okay, so let us enter into today's session now. So first, what is polynomial? So look at here. So that is a general form of a polynomial. So that is a general form of a polynomial. Okay. So p of x equal to a n x to the power n, a n minus 1 x to the power n minus 1 plus etc. plus a 2 x square plus a 1 x plus a naught. Okay. For example, 2x square. Okay. 2x square plus 3x plus 5. Okay, so that is an expression, right? It contains 3 terms here. Okay, so you already know about equations. Okay, equations. So here the difference is there between equation and polynomial. Suppose if we put this one equal to any other number, for example 8 or 0, anything means, so this one comes under equation because equal symbol is there. So here also equal symbol is there, but it is not comes under equation. Okay, it is called a polynomial function. Okay, so look at the left hand side. It is denoted with the function p of x. So the function is nothing but the representation of an expression with a particular variable. Okay, so p of x means, so this is an expression with a variable x. That is the meaning. So inside of x, suppose here a n y to the power n, a n minus n y to the power n minus 1 plus etc. plus a 2 y to the power 2 plus a 1 y plus a naught. Suppose this an expression in terms of the variable y means we can represent that as p of y. So it is contains both x and y means we can represent that p of x comma y. Okay, so the left hand side p of x is nothing but it is the notation of an expression with respect to the particular variable. That variable mentioned inside the bracket like this. Okay, so that is the difference between equation and polynomial. So in equation, after equal symbol and left hand side of equal symbol, so only expressions and also some constant will be there. But in polynomial, so in one of the side it is represented by p of x, so like that, or g of x or g of y, whatever it is. Okay, so the expression denoted by the particular variable here, so it is represented by the function. Okay, so that is the difference between polynomial and equation, right? So this is equation here. Suppose if we write the same thing, that is 2x square plus 3x, so plus 5 equal to, this is here the expression denoted by the variable x. So we can denote this as with respect to x with another letter, that is q of x. Okay, so this is known as polynomial and this is known as the equation. And but both are expressions only, but one of the side only they will differ. So here constant or anything will come, but here only function will come. The function stands for the representation of the particular variable in the expression. Okay, so that is the general form of a polynomial here. Okay, so here a naught, a n minus 1, a2, a3, everything real numbers here. Already you know that what is real number? It is a combination of rational and irrational numbers. Okay, so in our example, so 2, 3, 5 or a1, a2, a3 like that, they are real numbers. Okay, and also one more thing, the powers should be a whole number. Okay, if the power is not a whole number means it is not a polynomial. What about here? So here 2, here 1, here 0, right? So the powers are whole number only, therefore it is a polynomial, right? So look at this example. So here 5x y square minus 3x plus 5y cube minus 3. It is an expression. Okay, so here equal to, we can define this as p of, so how many variables are involved here? X and y. So x comma y. So we can represent like this. Instead of putting p of x comma y equal to any number 0 or 2, anything with a constant means it is not a polynomial, it is an equation. Okay, so it is a polynomial now, right? So how many terms are here? So 1, 2, 3, 4 terms are here. Okay, and here the powers, look at the powers here. So 2, 3, here in this variable nothing is there, so 1 will be there here. Okay, so nothing is there in the power of the variable means we can take that as 1. So here 2 and 1, here 3, so this one constant. Anyway, the term without variable means that is called a constant term. Okay, so it is a polynomial definitely. And look at here, they are not a polynomial given here. Why it is not a polynomial? So look at the variable here. So variable, the power of the variable x is nothing but 1, and what about the power of the variable y? It is minus 2. Okay, it is minus 2. As I already told that an expression should be a polynomial means the power of the variable should be whole number. So here 2 whole number, 1 whole number, 3 whole number. But what about here? 1 whole number, that is x power 1, but y to the power minus 2. So it is not a whole number, therefore it is not at all a polynomial. However, it is a combination of variables and constant, expression only, but it is not a polynomial because of the power. And look at here. So 2 divided by x plus 2, the variable is in denominator. Okay, if you bring that in the numerator means the power of the variable should be negative. Okay, when we transpose the variable from bottom to top, that is from denominator to numerator, it will become opposite sign. For example, 1 by x square is there. Okay, so when we transpose this variable to the numerator, it will become 1 into x to the power minus 2 only. Okay, therefore when we transpose this into the numerator, it will become x power minus 1. So minus 1 is not a whole number, therefore it is not a polynomial. Okay, look at the next example. So these are the definitions, these are the examples of the polynomial, because look at here, it is an expression, this one also expression, this one also expression, and this and all the examples for the non-polynomials. Okay, so compare these two now. It is also an expression, so it is also expression only, but look at the power. So the power of the variable here, whole number. So here x to the power 1 is there, that is also whole number. What about here? The power of the variable is nothing but minus 1. It is not a whole number. But what about here? Here whole number only. But every power of the variable should be whole number. Then only it is called a polynomial. So it is not a polynomial. And similarly, what about here? So x to the power 3. Okay, the coefficient may be minus. Okay, but the power should be a positive number, that is whole number. Okay, so it is a polynomial. And what about here? Root of x. So how can we write root of x in another way? So x to the power 1 by 2. So 1 by 2, is it a whole number? No. So 1 by 2 is not a whole number. Therefore, it is also not a polynomial. And what about here? So power 4, 3, 2 and power 1. Therefore, everything whole number only. So that is a polynomial. And what about here? So 3 by x plus 5. If we bring that x in the numerator, what will happen? X to the power minus 1. Okay, so we can find out the power in the numerator only, so that we can transpose all the variables into the numerator. So look at the power of the variable now, it is minus 1. Okay, so it is not a whole number, therefore it is also not a polynomial. Simply we can say that in an expression the power of the variable should be whole number, then that expression is said to be a polynomial, otherwise it is not a polynomial. Okay. So next definition, degree of the polynomial. So how can you find out the degree of the polynomial? So look at the definition, the highest power of the variable. So highest power of the variable in a polynomial is known as degree of the polynomial. Okay. So look at the example here. So it is a polynomial or not? Check first if it is a polynomial or not. So polynomial means it should be the linear combination. That means it should be the combination of variables and a constant. So it is a combination of variables and constant only. How many terms are here? So 3 terms are available. Okay. And then check the power now. Okay. Look at the power. So here 2 and here 1. Therefore both are whole numbers. Therefore it is a polynomial. Right. So from the polynomial, what about the term 1 here? That is the first term. What about the power of the variable in the first term? 2. And power of the variable in the second term? 1. And power of the variable here, variable is not here, but you can take y to the power 0. Because anything power 0 is 1. So if we want to write any constant, okay, if you want to write any constant as the variable, for example 7. How can you write, 7 is a constant, we know that, but how can you write this 7 with a combination of variable? So 7 into x to the power 0, because x to the power 0 is nothing but 1. So 7 into 1, 1 only. Okay, or y to the power 0, anything you can write, right? So here the term, first term contains the variable, the power as 2, and second term having the power as 1, and the third is 0. So which one maximum here? 2. Therefore the highest power of the variable is called degree of the polynomial. So 2 is the degree of the polynomial, right? So next types of the polynomial. Okay, so many types of polynomials are available. So we can classify them according to the terms and also according to the degrees. So according to the terms, already you know that. Okay, so look at here, according to the terms, the polynomial can be classified into monomial, binomial, trinomial, polynomial as it is in your algebraic expression. Okay, so look at here. So how many terms are here? Only one term, but 2 coefficients are there, 2 factors are there. They are in multiplication, so that you can take it as only one term. So that is monomial. Look at here. So 2 terms are available, so that it is called binomial. And look at here. So here 3 terms are available. Therefore, you can call this as trinomial. And look at here. So here 4 terms are available, so it is called a polynomial. So an expression with 4 or more terms, we can call them as a polynomial. Okay. So according to the terms, we can classify the polynomial like this. Okay. So next, according to the degree, how can we classify the polynomials according to the degree? So listen here, a polynomial having degree 1 means it is called a linear polynomial. For example, look at the example here. Look at the 3 examples here. So the power of the variable is 1. Here also power of the variable 1. And similarly here power of the variable 1. So it is a maximum power of the variable. Therefore degree of the polynomial is 1. Therefore it is called a linear polynomial. Okay, look at this. So this it is also a polynomial, but power of the variable is 2. And here also power of the variable 2 and power of the variable 2. So this is a maximum value. Therefore it has a degree 2, and the degree 2 is nothing but quadratic polynomial. And cubic polynomial means the degree, a polynomial with a degree 3 is known as cubic polynomial. And a polynomial without any variable is known as constant polynomial. That is, the degree of the constant polynomial is 0. So how can we define simply? A polynomial with the degree is known as linear polynomial. Okay, a polynomial with the degree 2 is quadratic polynomial. A polynomial with the degree 3 is a cubic polynomial. A polynomial with the degree 0 is called a constant polynomial. Okay, so let us continue from the next video.